All right, let's get into it. Today we're doing a deep dive on a piece of tech that's really the unseen backbone of complex video setups.
Yeah, exactly.
We're talking about the NTI SM-8X8-DVI-LCD. It's a DVI video matrix switch.
And that sounds super technical, but really you can just think of it as like a digital distribution brain. It takes video from a bunch of sources,
Computers, satellite receivers, anything really.
up to 32 of them in the
Yeah.
biggest version.
Yeah.
And it routes them to up to 32 different screens. And,
Yeah.
the price for the base 8x8 model, it's about $195.
Which immediately tells you something. This isn't for your home theater. This is serious industrial-grade hardware.
Absolutely. It's built for reliability.
So let's talk specs for a second. It's single-link DVI-D, and it handles your standard HDTV resolutions, up to 1080p. But the really key number for the pros is 1920 by 1200.
WUXGA. Yeah, and that tells you exactly who this is for.
Who is it for?
It's for anyone running high-end legacy systems. Think engineering workstations, medical imaging, control rooms, places where WUXGA was the gold standard long before 4K was even a thing.
That makes sense. So it's versatile. And speaking of versatility, it's not just for one type of system, right? The sources say it works with, well, everything.
Windows, Linux, Mac OS, Solaris. It's totally OS agnostic. The hardware doesn't care what software is sending the signal.
Which is how it should be.
And that hardware flexibility is where you find the really interesting stuff.
Okay, like the HDMI connectivity. This is the part that surprised me. You can pass a full HDMI signal, audio and video, straight through its DVI port.
As long as you have the right cable, yeah. The DVI HDXXMM, it just works.
That is a lifesaver for anyone working in a mixed DVI and HDMI environment.
It is. And to make sure all that mixed gear actually talks to each other properly, it has ED learning.
Explain that for a second. Why is ED so important here?
Well, ED is basically how the display tells the source, hey, this is the resolution I can handle. This box can learn those codes or use default ones for PC and Mac.
So it prevents the dreaded blank screen.
It prevents the blank screen, the flickering,
Yeah.
all those handshake issues that drive installers crazy. It's a core reliability feature.
And since it's a central brain, how do you actually, control it?
A bunch of ways. You can use Ethernet with standard protocols like HDTV or just TCP/IP.
Okay, so network integration.
Yep, or a simple serial port, the button's right on the front panel, or even an IR remote. It's designed to fit into a secure data center or a simple control room.
Now let's get to the part that really sets this thing apart.
Yeah.
Scale. The distances here are just wild.
They really are. You can hook this switch up to fiber optic extenders, the ST2FO-DVI-LC units, and push a DVI signal up to 4,920 feet away.
Almost a mile. That's incredible.
And for the really huge 32 by 32 model, NTI actually built the power supplies for those local extenders right into the main unit.
Ah, so you don't have a huge mess of wall warts and power strips.
Exactly. It's clean. It's designed for massive, tidy installations.
Okay, but with all that power, there has to be a catch. There's always a catch, and it seems like it's HDCP.
This is the big one, the so what of the whole thing. The device does support HDCP for protected content,
Right.
but only on a one-to-one connection. So one input to one output. The second you try to split one HDCP protected source to multiple displays,
Compliance is broken. It won't work.
it won't work. And for anyone handling copyrighted material, that's not a small detail. That's a system-defining limitation you have to design around.
That is a critical piece of information. But to balance that limitation, the hardware itself is built to last. I was looking at the MTBF numbers.
Mean time between failures,
Yeah. For the 8x8 model, it's 90,801 hours.
which is, what, about 10 years of running 247?
Over a decade of continuous operation. That just screams mission critical. This
Right.
thing is engineered to never, ever fail.
So that's really the trade-off, isn't it?
Yeah.
On one hand, you have this incredibly robust, scalable piece of hardware that can run for a decade without a problem.
But on the other, you have this very specific, very hard limit on how it handles protected content.
So the final thought for you to think about is this. When you're designing these complex video networks, how do you weigh those two things? What's more valuable, sheer distribution power and redundancy, or strict content compliance? Where does the industry draw that line?